So now that you know how to do moles to moles calculation using a balance equation, let's do mass to mass calculations, which involves nothing more than taking the mass, using molar mass, and make it into moles, and then you can do mole to moles conversion. So that's what we're doing. We're still gonna be doing conversions, but we're gonna start with mass and we're gonna end up with mass, and we're still gonna do it between reactants and products. And we're using a balance equation, like before, and molar masses to find out the conversion between the grams and the moles. Let's begin with these two problems. For each of these reactions, so we have reactions A and reaction B, calculate how many grams of the product. So we're gonna find the grams of calcium carbonate for the first one, and the grams of magnesium oxide for the second one. When 2.4s of the reactant in color are used. So if I start with 2.4 grams of carbon dioxide, can I find how many grams of calcium carbonate can I make? Well, every time we want to convert from one substance to another substance or one formula to another formula, there's no way but using mole to mole conversions. But we are not starting with moles, we started with grams, so I definitely want my moles instead of the grams. So the grams of CO2 and the moles of CO2, that's the molar mass. 1 mole of carbon dioxide is 44.0 grams. So now that I cancel the grams, now that I have the moles of CO2, I do not want the moles of CO2 because I really want the moles of calcium carbonate. And this is mole to mole ratio. So I'm gonna go to my balance equation. For every 1 mole of calcium carbonate, I need 1 mole of CO2. But I don't really want the moles of calcium carbonate because what I want is the grams of calcium carbonate. Therefore, I do not want the mole of calcium carbonate. And that's nothing more than molar mass, grams over moles. So I know that for every, let me check here quick, what would be the molar mass of calcium carbonate? The molar mass of calcium carbonate is going to be 100.1. It's gonna be 100.1 grams for every 1 mole. So when we put all that together, I'm gonna multiply 2.4 times 1 times 1 times 100.1 divided by 44, and that's gonna divided by 1, and that's gonna give me 5.46 grams of calcium carbonate. So let's review this. I began with the grams of calcium carbonate because I needed to find the grams of, I began with the grams of carbon dioxide because I needed to find the grams of calcium carbonate. So I'm gonna go from one substance to another substance. The only way to do that is by going from mole to mole. Since I don't have the grams of carbon dioxide, I use my molar mass of carbon dioxide to find the moles of carbon dioxide. Now I can use the balance equation to cancel my moles of carbon dioxide because I'm looking for the moles of calcium carbonate. That allows me to find the moles of calcium carbonate, but I do not want the moles of calcium carbonate because I want the grams of calcium carbonate. And when I do all that operation using molar masses and the numbers from the balance equation, I come up with 5.46 grams of calcium carbonate. So let's do the second one. If I begin with 2.4 grams of magnesium on this case, I do not want the grams of magnesium, because I'm looking for the moles of magnesium. And I know that for every 1 mole, there are 24.3 grams of magnesium. That allows me to cancel the grams of magnesium. That leaves me with the moles of magnesium, but I do not want the moles of magnesium because I want the moles of magnesium oxide. I get that from the periodic table, so 2 moles of magnesium oxide for every 2 moles of magnesium. But I do not want the moles of magnesium oxide either, because I want the grams of magnesium oxide. And 1 mole of magnesium oxide is, I tell you in a second, 1 mole of magnesium oxide is going to be 40.3 grams. So at this point, I proceed to use my calculator. I multiply everything on top, 2.4 times 1 times 2 times 40.3 divided by everything at the bottom, 24.3 divided by 2 divided by 1. And that gives me 3.98 grams of magnesium oxide. So once more, from grams of magnesium, go to the moles of magnesium. From the moles of magnesium, go to the moles of magnesium oxide. And from the moles of magnesium oxide, go to the gram of magnesium oxide. And that's how we go from mass to mass. So you should be able to approach this problem now. And on this particular problem, I want you to find, based on 10.8 grams of hydrochloric acid, I want you to find how much sodium chloride you can make, how much water you can make, and how much carbon dioxide you can make. So you're going to have 3 different answers. After you do that, then you're doing, let's see, you're basically doing the same thing. Yeah, so do not do 8.3b because it's the same thing. I was going to change it, forgot to change it. Sorry for that. And with that, you should have enough practice and a deeper understanding on how to go from mass of one compound to mass of another compound using the molar masses to change it to moles, and using a balance equation to use the mole to mole ratio once you find the moles. And with that, we finish this section. When you come back, we're going to start talking about limit and reactant, theoretical yield, and percent yield. So see you soon.